Hello children, you are welcome to this segment of the program, The Classroom in Your Home. It is mathematics time, and that means it is time to have some fun. Hi, I'm Uncle Agbaje. Today in mathematics, we will continue our work on lines and angles. But before we proceed into today's work, we'll begin with the review of the correction to our last homework. You were asked to identify all the angles that are vertically opposite each other in the diagram, and also to identify the lines that are parallel. Let's see what the answer is looking like. Angles 1 and 3 are vertically opposite each other, and that means that they are facing each other at the corner or at the junction. Angles 2 and 4 are also vertically opposite each other, and that means they are facing each other. Or you remember that we identify vertically opposite angles at the X junction, angles that face each other. Also, angles 5 and 7 are vertically opposite each other. They face each other at this junction. Angle 6 and angle 8 are also vertically opposite each other. They face each other at the junction. That's how you identify vertically opposite angles. Now, lines UV, this line, and line XY, this line, are parallel. That means they are having equal distance between them at every point. I believe that these are the answers that you wrote down, and for that I will give you a cheer. Now, moving on to today's work, we'll begin with a review of what we're expected to achieve at the end of this lesson. By the end of this lesson, you should be able to find the complements of angles. You should also be able to find the supplements of angles. Complements, supplements. What exactly are they? They are not the same supplements that you use when you finish eating your food. They are not drugs. You'll find out what supplements are in mathematics very soon. Finally, you should be able to find missing angles on a straight line and at a point, using your knowledge of complements, supplements, and every other thing that we have been learning. So let's just move right into it without wasting much time. So what exactly are complements and supplements? I want you to study this diagram. What kind of angle is this? You already know it. I can hear some of you saying, oh, I know this one, it's a right angle. Yes, you're right, it's a right angle. But what does it measure? How many degrees are there? There are exactly 90 degrees in a right angle. Now, I want you to study this other diagram. What is the relationship between the lines AB and line AC when you have a right angle in between them? We call these lines, we did that in the last lesson. Do you remember? What do we call lines that meet at right angles? We call them perpendicular lines. They are perpendicular lines. AB is perpendicular to BC. Now, study this diagram. The question says, what is the value of angle X? This symbol on top of X means angle, whatever you say that. What is the value of angle X? Now, you know that the whole of this is a right angle, and that means the total is 90 degrees. Well, moving from this point to this point, we have 32 degrees. So what is X? You should be calculating your answer right about now. What is that angle? Well, let's see what that is. Well, we know that if we add 32 and X together, we'll get 90 degrees. So that means that we'll take 32 to the other side to solve this equation. Plus 32 becomes minus 32. And you have 90 degrees minus 32. And finally, X is 58. Telling you that if you move from here to here, 32, you have to move 58 more degrees to equal the total of 90 degrees. Now, these angles, 32 and 58, that you add up and they give you the right angle, we call them complementary angles. These are what we call complementary angles. Say complementary. Complementary angles. So in this case, 32 is the complement of 58 because 32 will add to 58 to get 90. 58 is also the complement of 32 because 58 will be added to 32 to get 90. When you're asked to find the complement of an angle, it means what will I add to it to get 90. Let's see some examples. What is the complement of 53? Calculate that quickly by yourself. It means what will I add to 53 to complete the journey? I'm starting from here, I move 53 degrees. How many degrees must I move to complete the journey to 90? Because everything is 90. Now, your answer should be 37 degrees. I'm sure you got that right. The complement of 53 degrees is 37 degrees. What is the complement of 63.5? And that means what will you add to 63.5 degrees to get 90 degrees? Calculate that quickly. You start your journey from here and you take 63.5 degrees steps. Now, how many degrees more do you need to go to get to 90? Your answer should be arriving on your books by now. You should have 26.5 degrees. And 26.5 degrees is the complement of 63.5. Don't forget once again that the complement of an angle is what you will add to it to complete 90 degrees. Let's see how we can find missing angles in diagrams. Study this diagram. The question says, what is the value of angle K? Do not let the diagram itself scare you because you're a genius. All you have to do is look at where the angle is starting from and look at where it's ending. It's a straight line. It's starting from here and it's ending here. And you know that angles on a straight line, everything must add up to what? They must add up to 180. And that's exactly what you're going to work with. So let's see how this is solved. This is the same angle that has been reproduced here. So what we now do is that starting from here, or starting from here and ending here, get 180. So we know that this is K. We know that this is 23. Then what is this one? This angle, of course, you know, is what? Is 90 degrees. So we had all these three angles together because there are three angles on the line. Let's go. So it says 90, which is this one. You don't need to be told. The box represents 90. That's it. So from here to here, 90. Now the next one is 23. This one, you write it out. Then the next one is K. You write it out. Now all these three angles must add up to 180 degrees. So all you have to do, my friend, now is to use your knowledge of open sentences to solve this. So adding 90 and 23, you get 113, which you will have to move to the right side. And we do that on the next line. K comes down, 113 becomes minus 113. So now subtract 113 from 180, my friend, and you get 67, telling you that K here is 67 degrees. This next example says, what is the value of angles M? This one. And angle V. This one. Now, as I have said earlier, do not let the diagram itself confuse you. Study it and ask yourself, what do I know or what can I find from this diagram? What have I been given? So let's see how Nkokwaje is going to put us through this word. So this is the same diagram that has been reproduced here. But now you observe that angle V is vertically opposite to 32 degrees. I mean, they're covering each other. Can you see? And they are this junction here. So they are directly facing each other and they are vertically opposite. And you do remember that vertically opposite angles are always equal. And so because of that, there is no calculation involved. V and 32, all you have to do is state for Nkokwaje or your teacher, V and 32 are vertically opposite angles. And because they are vertically opposite angles, they are equal. And that is just it. That's what we have here. V and 32 degrees are vertically opposite, and because of that, they are equal. So let's see how we're going to get the angle M. Remember that V now is 32. Now, study this straight line. V, 75 and M are on this straight line. That is, if you move from here and you get to this end, that's 180 degrees, if you remember. So that's exactly the relationship that we are going to use. So let's see that in action. So we have 75 plus m plus v. All of them are on this side of the straight line, and that means that they are equal to 180 degrees. Now, we know that v is 32, so we have to change that. So instead of writing v again, we already know that v is 32. We got that one in the previous slide. So instead of writing v, write 32, bring down m, then add 75 and 32 together, you will get 107. Bring down the m, and on the other side, bring down 180 degrees. Then you have to move the numbers to the right so that you can find m. And that's exactly what we're going to do. Remember that 107 we change to minus 107 across the bridge. So now all you have to do is just do the subtraction, my friend, and you will get 73, telling you that your m is 73 degrees. So we got v to be 32, and we got m to be 73. Okay. So we got m to be 73 degrees. So let's move on. This one is for you to do. I'll give you 1 minute to study it. Int, you have to find the values of A, B, and C. So I want you to begin by looking for which angles are vertically opposite. You have 1 minute. Begin. Eyes on me. I believe you've gotten your answer by now. Let's just see how it's going to be done. So now, easy to see that A and AT are vertically opposite, and that means that they are equal. So A is equal to AT. Also easy to see is the fact that C and 25 are vertically opposite each other, and that means that C is 25. So you've gotten those two already. You've gotten 2 out of 3 without even calculating anything. So let's see how the last one is going to be gotten. So A is 80 and C is 25. All we have to do now is add A, B, C because they are on the same side of the straight line, and we'll get this one. And we'll get 180. So now A plus B plus C on a straight line means that all of them add up to 180. But A is 80, C is 25. You bring down B, then you add. 80 and 25 will give you 105, then B comes down. Now you take 105 to the other side, remembering to change the sign. Now B is 180 minus 105, and that means that B is 75. So this is 75, this is 80 because it is vertically opposite to this one, and this is 25 because it is vertically opposite to this one. I believe that is what you got, my friend. If that is not what you got, then you probably need to recheck the steps, and you find get another opportunity in the assignment, which is coming up right about now. I want you to take 30 seconds to capture this. And remember that today is Tuesday. Uncle Agbaje will be back with the Magic Tuesday segment. Stay tuned. You're welcome to this segment of the program. It is Magic Tuesday, where I show you a lot of tips and tricks on how to navigate the field of mathematics. The last time we had this segment, I showed you how to square numbers that end with 5. Today I want to show you something quite interesting. Let's see what it's all about. Today we will learn a new method of multiplying numbers. I mean, there's this method we are taught where you have to write one another number below, and then you have to start arranging, and then you add everything. And sometimes even I as a teacher, I get confused. Do I put it under this one or do I put it under this one? You discover that if you do not arrange the numbers well, your answer is always going to be wrong. But here I'm going to teach you a method where you don't have to even write any number. You just have to draw lines and count dots, and you will get your answer. Let's see how this is done. Example says multiply 23 by 12. And so what we're going to do is that we're going to draw a line to represent 2, 2 lines to represent 2, and 3 lines to represent 3, like this. 2, then 3, and that stands for 23. Now I'm going to draw 1, and then another 2 line below. So this is 1 and this is 2. So this represents 2, 3, 1, and 2, like that. So what I'm now going to do is that I'm going to identify the intersection point where all the lines meet, like this. See, lines meet here, lines meet here, lines meet here. See, all these points where the lines meet, I identify them. Now all I have to do is now count diagonally. You remember diagonal lines? Not vertical, not horizontal, diagonally. See this diagonal, the way it's pointing. So I add up all the dots this way, all the dots this way, and all the dots this way. I'll just use a circle to guide you, like this, so that you don't miss your way. Now it's time to count. Here I have 6 dots. Here I have 1, 2, 3, 4, 5, 6, 7, 7. And here I have 2 dots. And that, you now read your number like this. Your final answer is 276. Isn't it interesting? Let's take a look at another example of the same type. This one here says multiply 31 by 21. So again, I'm going to draw 3 lines, 1 line, 3 lines, 1 line, and I'm going to draw 2 lines, 1 line, 2 lines, 1 line. Now I'm going to count all the intersection points. First I identify them. These are the intersection points, 1 here, 2 here. Now I count them diagonally, and just to guide me, I draw circles. See how it's drawn? This way, and this way. Then of course everyone can count. Here I have 1, here I have 1, 2, 3, 4, 5, so write it here. Here I have 1, 2, 3, 4, 5, 6. So my final answer is 651. It's as simple as that. Let's just take a look at something that involves carrying as our final example. This one says 213 multiplied by 41. Now I draw 2 lines for 2, 1, and then 3. That's 213. And I draw 4 lines and then 1 line, and that is 41. Now of course the next thing to do is to count all the intersection points. I've highlighted them for you. Now I count diagonally, and now there will be 4 diagonals because 1 will be coming this way, 1 will be coming this way. If you let it come like this and you go like this, that is no longer a diagonal. So you just come straight and you capture this, and then from here you capture this, and then from here you capture this. Let's draw circles to guide you. So you can see they have to be diagonal. Now it's time to count. Here I have 8, here I have 6, here I have 13. You see, it doesn't really matter which one you count first. Just put all the numbers below. But now there's going to be a problem somewhere. We have 1 digit, but we have 2 digits here. So what you do is that you carry 1 digit from here and take it to the next place, like this. So this one comes here. 6 plus 1 gives you 7. And so your final answer is 8,733, as you can see. I mean, this multiplication method works for low digit numbers. You might want to try it by yourself once in a while, and you discover that you will not have problems with multiplications. That has been interesting for me. I hope it has been interesting for you. Till I come your way next time, remain wonderful mathemagicians.